In this video, I am going to show how to find volume using trigonometric substitution. So let's get started. The region bounded by the graph of f of x equals 1 over 1 plus x squared, and the x-axis between x equals 0 and x equals 9 is revolved around the x-axis. Find the volume of the solid that is generated. Well, as always, the first thing we want to do is to go to Desmos. And so I already graphed this in Desmos, and this area between x equals 0 and x equals 9 is all above the x-axis. And so I am going to simply take this and draw a simple little diagram on my axes here. If I can find my cursor, there's my cursor. And so we're going to look something like this. And so we'll make 9 right here, and then of course 0 is over here. I'm going to make that a little bit bigger. Okay, so our region R is right here, and I'm going to draw a representative rectangle. And this is what the representative rectangle would look like. The width of the rectangle is along the x-axis, delta x, so we'll be integrating along the x-axis. And the easiest method to use for this would appear to be the disk method, the good old disk method. And so the formula for the disk method is volume is equal to the integral from a to b of pi times f of x squared dx. And so remember that f of x squared represents the radius squared because of this little rectangle. The radius is the distance from the axis of rotation to the curve, was the height of the rectangle, which is acting as the radius of the disk that is being created. And so it is simply going to be the radius squared, or the function value squared. Well, the function value and the bounds of integration are all known. We're going from 0 to 9 times pi times 1 over 1 plus x squared quantity squared dx. Now, when you first look at this problem, it doesn't look like a typical trigonometric substitution problem. And the reason for that is because we don't have a radical. We're used to seeing the typical form for trigonometric substitution being something like the square root of 1 plus x squared. So let's see if we can use trigonometric substitution without the radical and have it work for us. Never hurts to try. So if I was to let x be equal to the tangent of theta, a tangent theta, because this is basically what this form would be. If we had a radical here, what we would be doing is we would be using a tangent theta. In this case, a is simply 1, so x is going to be tangent theta. Let's substitute that in here now. So volume is equal to pi. I'm going to pull my pi out in front because it's a constant. The numerator squared is just 1, and then the denominator 1 plus x squared dx is what we have here. And so substituting in, I'm going to have 1 over 1 plus tangent squared theta squared, and dx, well, the derivative of tangent is secant squared theta. So then dx becomes secant squared theta d theta. Well, in the denominator here, 1 plus tangent squared is secant squared. And so secant squared being squared is secant to the fourth. So volume is equal to pi times the integral from 0 to 9 of 1 over secant to the fourth theta times secant squared theta d theta. Well, you can see that a lot of secants are going to cancel out. We're going to have volume is equal to pi times the integral from 0 to 9 of 1 over secant squared theta d theta, because 2 of these cancel with 2 of those 4. But I'm going to change that even more. I'm going to make that pi times the integral from 0 to 9 of cosine squared theta d theta, because cosine is the reciprocal of secant. So we have a very nice little integral, and we can now use what we've learned about trigonometric integrals, which means we will change this to 1/2 plus 1/2 cosine of 2 theta. And I'm going to break this into 2 integrals. Let's just keep the pi out here. And so we're going to have the integral of 1/2 d theta plus 1/2 integral of cosine of 2 theta d theta. All of that times the pi. So let me put my there. And now actually integrating this, the volume is going to be equal to pi times 1/2 theta. And so we're going to have 1/2, and this is going to be u substitution, where u is equal to 2 theta, du dx is equal to 2, and so dx is equal to du divided by 2. And so we're going to end up with a 1/2 sine of 2 theta. So volume is equal to pi times 1/2 theta plus 1/4 the sine of 2 theta. We don't want a double angle. Sine of 2 theta, we would prefer to have sine of theta. So once again, we can use the trigonometric identity that the sine of 2 theta is 2 sine of theta cosine of theta. So substituting that in there, pi, and we have 1/2 theta plus 1/4 times 2 sine theta cosine theta. And then 1/4 times 2 becomes 1/2. We're going to have pi times 1/2 theta plus 1/2 sine of theta cosine of theta. And there we go. Now, we're supposed to be evaluating this from 0 to 9, but remember that 0 and 9 are x bounds, and I did not change my bounds from x's to thetas. I could have done that. But I chose to leave them as x's because I want to go through the process of converting back into x's, just so that we become nice and familiar with how to do that. So we create a right triangle. And so remember, the tangent of theta was defined as x, which would be x over 1. So tangent is the opposite side over the hypotenuse, the adjacent side. And so this side is going to be the square root of x squared plus 1. If tangent of theta is equal to x, then theta is going to be equal to the arctan of x. Likewise, we need to find sine of theta. Sine of theta is going to be the opposite side, x, over the hypotenuse. Cosine of theta, the adjacent side over the hypotenuse. So putting all of that together, volume is equal to pi times 1/2 theta, which is 1/2 the arctan of x, plus 1/2 sine of theta, which is x over the square root of x squared plus 1, times cosine, which is 1 over the square root of x squared plus 1. Now, these two radicals in the denominator being multiplied together, the radicals, it's basically x squared plus 1 square root squared. So we can simplify all that. So volume is equal to pi times 1/2 the arctan of x plus x over 2 times x squared plus 1. Now all of this is being evaluated from x equals 0 to x equals 9. Well, when you go through and do that, and you can do that in Desmos if you would like, it's the way I usually do it. When you do that in Desmos, you are going to end up with a volume equal to approximately 2.46. So just go ahead and put 1/2 arctan of 9 plus 9 over 2. We'll just put the function in there and then evaluate in Desmos. And you will get volume is equal to approximately 2.46. So that is how you can find volume using trigonometric substitution. And in this particular case, the disk method. It was a situation where it didn't look like you would want to use trigonometric substitution because of no radical, but sometimes it works even when we don't have the radicals, depending on the nature of the problem. All right, that's it for this video. I hope it was helpful.